Why does light travel in a specific direction? In the energy filament theory, light is not a particle but a rhythmic pulse within the energy sea. When we talk about disturbances, you might naturally think of water waves. When you drop a stone in water, waves spread out in circles in all directions. So, a natural question arises, if light is a disturbance, why doesn't it spread out evenly in all directions? Why does it move in beams? The answer lies in a core idea we discussed in Season 2. Everything particles, atoms, molecules, matter maintains structural stability through near-field texture interfaces. In simple terms, everything stable is surrounded by invisible textures. These textures are not random, they have patterns and directionality, like a set of teeth locking atoms and electrons together, or spirals that lock the entire structure in place. The energy filament theory calls these spiral textures. Every structure in the universe is defined by these spiral textures. These spirals have direction. Some directions are tight, others are more relaxed. Some directions allow movement to escape, while others seal it in. When an electron moves from a high energy state to a lower one and needs to release extra energy back into the sea, it doesn't choose to move left or right. It doesn't even have a menu of options. It simply releases energy in the direction already opened by the spiral texture. In other words, direction is not formed after light is emitted. It is decided at the beginning, chosen by the open paths of the spiral textures. From the perspective of a single particle, at the moment light is emitted, the directions on the spiral texture that are open and closed have already been set. The extra energy can only escape through the open directions. That's the direction of the light emitted. On a larger scale, an object, an atomic cloud, or a star contains countless particles, each with its own spiral texture, pointing in different directions. Each light emission through its interface releases a pulse of disturbance. When these pulses combine, they create what we see as light spreading in all directions. We recommend revisiting Season 2, where we discussed particle shapes and near-field textures in more detail. For more, check out the next episode, Why Can Light Travel So Far? Follow and share to help spread the new physics and explore the true nature of the universe.